In this project, the main software used is PTC Creo Parametric 3.0 to develop our skills learning in class and have a hands-on experience with a challenging project. The radio control car was a demanding project for our time, skills, and crucial thinking to get a reduced in area and weight. The main objective of this challenge is to make a dynamic, modern, innovative, and faster car. In this video, the topics to discuss are steps for the project, how it functions, the design, engineering behind it, analyze the 3D printing model, and the problems faced by the team. Follow me and we will show you the process to this project.
The first step was to assemble the original car to be able to notice what were some factors that we could affect our design. So, some factors that we have in mind is the weight, the design, speed, and control of radio control car. After we had all the cars disassembled, each part was measured with the caliper. Some parts were troublesome because their size and form, for example, angles. Tolerance have to be contemplated because some tiny parts were too tiny and the measure was estimated. And after we have all the components of the car, all the parts were separated in groups depending the position and size. Then the team brainstormed to start the design on Creo to have a 3D version. A main design was made and then printed, but we had to do some readjustment and then print it again. The details of the printing are going to be explained later in the video.
One of the main components of the car is the suspension. The main components of the car suspension are the chassis, the springs, and the anti-sway bar. Those three components are responsible for smoothing out the ride and keeping the car in control. This minimizes the friction between the tires and the road to provide stability and good handling.
How do the different components work together? To answer this question, the transmitter sends radio waves to the receiver. The receiver has an antenna and circuit board inside the toy which receives signals from the transmitter and activates motors inside the toy as commanded by the transmitter. The motors can turn the wheels, steer the vehicle, and operate propellers. Okay, so the outer casing keeps everything and all the components in one piece. The inner casing protects the small components. The batteries supply power to the car. The front lever wheel axle allow the car to turn and keep moving. The rear wheel and axle allow the car to move forward and backward. The springs act as shock absorbers, and the motor converts electricity into motion to move the wheels.
So why is the design like this? The engineering behind this design is that will help the car to be weightless, and also it will help the physics of the air to make it faster and lighter. Also, we have these parts that help the air to go in. And also, the main purpose of this design is to use less plastic, to make it weightless, and this will help to be a more recyclable material. And when it goes to the industry, it will be easier to produce. Also, this design was changed several times because it's a try and error project. Another important part of the car is the shell, since it needs to be aerodynamic. It is important to take into account aerodynamics during the design of the car because it improves fuel efficiency, high speeds, more stability at higher speeds, and reduced noise levels. Some devices that help aerodynamics on a car is to add wings, a spoiler, or a scoop. In this case, scoop were added on the sides and the spoiler was added on the back. Aerodynamics is the science of how air flows around and inside of objects. When the objects move through air, forces are generated by the relative motion between air and the surface. Frontal pressure is the form of drag where the vehicle must push air molecules out of the way and it travels through the air. This will influence the car since the millions of air molecules approach the front of a car and then they begin to compress, and in doing so raises the air pressure in front of the car. At the same time, the air molecules travel. The addition of the spoiler and scoop of the car help because the spoiler acts like a barrier for airflow. Low pressure is created above the car which lifts the rear of the car. So, they create high pressure that pushes down the car. The scoops helps as an opening that permits an adequate volume of air to enter directly. They provide high pressure, dense and adequate volume of outside air directly into the engine compartment. For this part of the project, 3D printing is a crucial factor because it is the main result. 3D printing, or additive manufacturing, is the process of making three-dimensional solid objects from digital file. The creation of a 3D
explain the major difficulties that we face during the first printing we have. This is the first example we 3D print, and as you can see there are several drawings we did on the main component. The black drawings we have are the things we add to the final 3D printing we did. As I said, there were several problems. The first one was this major problem. Since we 3D printed it with an infill of 2%, this is the major cost it will do. Another thing is this thing. Since we faced a lot of trouble with the support we added, because we thought it would be a good support for the car, not for the 3D printing this thing.
Another problem we faced is that the components would not stay. So we added these little barriers to make the battery stay and the transmission and receiver stay. Okay, so we took this out because it was just a design that was not necessary. It wasn't useful for anything else rather than look good. We also added more percent for the fill so that if it were to bump somewhere or into something, it would last a lot more than this. As you can see, this is very weak.
The second print, we have to understand that there has been a lot of failures, a lot of things that we have to understand that it is not easy to make it to the first time. The second 3D print, or the final, we can say, it has a lot of defects. After a long time of hard work, we already finished the final design of the 3D printed car, Cesaretti, and we face a lot of difficulties here. To add the suspension, the rear suspension and the front suspension, we had to adequate the car in order to position. In order to add the rear suspension, we had to adequate the car to the necessities that it has. And one of those is by adding manually we put the screws on their place. It was already easy for us to put the suspension, the springs on their right place or the desired place. In this case, we just add the rear suspension to the car, since the most important things was located on the front, on the rear part of the car. The front suspension wasn't added due to some difficulties that we have.
The challenge we faced was having to print the car in 3 parts. So in order to avoid fractures if it were to bump into something, we had to think of a creative way to put it together. So we used super glue, but that was not all we used. But we manually melted filament to make it stick more and make it harder to break. So we already tested it. We have bumped into things as a testing method. Since the car is made of one piece, we faced difficulties when we were building the car in order to be able to fit our hand and put all the pieces together.
Make this do because it's configuring itself, it's calibrating all the stuff that it has. Several tests, we discovered that while 3D printing the front bumper of the car, there was a huge mistake that we didn't correct while doing it.
After several tries of testing the car and driving it, there was a fracture. So this was due to a filament jam while 3D printing. We thought we could fix it with super glue and melting plastic to make it harder, but once it bumped several times, this happened. It is too late to 3D print this whole part, there is no time, so what we thought of was to buy another sort of glue, which will be a clay type, and hopefully it works, and that's what we're going to try.
Some problems during the beginning of the project were the pieces. Since they were really tiny, it was hard to measure them. And also, the measurements needed to be inside the tolerance ratio, so we need to make sure that it was right. Another problem was the design. Since we were 4 in the team, we needed to work together to have a main design, but with all the ideas. Another problem was time. Our schedules were really difficult since we sometimes worked or we needed to study, and sometimes the printing was really hard. After the first process, which was the pieces, measurement, and the time, and the second process, the things that affected us were more challenging and added more problems. In this case was printing. Printing was a major problem since some of the machines were not available on time or they were used by another teammates. Also, they sometimes get stuck with the filament and we needed to start again. The average time for all the pieces to print was around 6 through 7 hours, So three pieces were really hard and we needed to do it twice. So it was kind of time consuming. One of the last problems was that the polymer did not quite supported the pressure when it crashed. So maybe it's because the polymer is really glassy and it gets really hard, but at the same time it's easy to break. This makes it more difficult for us to maintain it together. In conclusion, there were a lot of factors that affect our printing. It was a challenging project, but not impossible. However, it's not an easy task, and the team needed to work together to be able to handle all the problems that we had. Some of the printers needed to be restarted. Another important factor were that the printers were not capable of handling all the projects, and sometimes they get stuck, or they needed to restart and the project already started and it affected our time. For example, if it was a printing process from around 6 hours and you already had 1 hour and it gets stuck, you need to start again. So that really affected us. However, all the problems were overcome and we did the final design.